cardboard-aided design has let me make the mounting plate for the McPherson strut out of 3mm steel. The actual top plate of the strut is 8mm alloy. I'll now put a flange all the way around it to give it structural strength, and probably web the flange as well. This is the very back chassis member of the car, so I'm going to gusset the plate at all angles because it does tend to hang out in space and will need to be quite strong because it carries quite a pounding from the suspension. Warm bath for the birdies. That should be 15 degrees. That's 14.5. Adjustment is necessary. .9, 15 flat. The rear strut tower is firmly in place. The bump loads, of course, will come up, and while a lot of them will be carried in this very strong structure, there are two 12.5mm rods in tension running up to the back of the strut tower to carry the worst of the loads and to stop it hinging at this point. Now, there are rebound loads, particularly those controlled by the damper going up and down, and these rods really aren't going to be that effective in rebound, but this is a very strong point here, and I've got the option of flanging it further. I've put a lot of effort into setting up the height and angles of the rear axle and rear wheel, so that when I make the control arms, they are more or less right. I've only got maybe 5 to 10 mils adjustability in the rod ends, so I have to get it right in the first place. Absolutely no bending is carried through the control arm at all. These are made from ordinary mild steel ERW tube, in this case 19 mils with a 2 mil wall. I can only really use something as light as this because they are only going to be in compression and in tension. The other good thing about 19 mil tube is it goes straight up the back of the lathe, which makes it very easy to machine the ends. Having faced the tube, the next job is to turn down this bung so that it slips inside the tube, with just a collar on the outside to stop it slipping all the way. Right, that's the left-hand bung machined down, with just a little bit of a gap there to get good penetration with the weld. However, for this end with the right-hand thread, I ordered incorrectly and ordered a female rod end, which means I have to put a stud into the control arm to go to the rod end. The other issue is that a female rod end has less thread in it than a male rod end, so I actually have less adjustability using a female rod end. Somehow then I have to make a virtue out of a necessity. My approach to putting a stud in is a bit of a workaround. I'll use this high tensile 10mm bolt, and I'll put a sleeve around it so that it can slip inside the control arm tube. I'll be very careful about how much welding I'll do, so basically I'll weld around the head and around the end of the tube. That way I won't overly damage the temper of the whole bolt, and it'll still remain high tensile through 90% of its length. The sleeve therefore can telescope inside the tube, which will allow me a fairly precise setup of its length, because in reality, at least at this end, I've only got 5mm adjustment range if I'm to retain 1.5 thread diameters inside the rod end. Okay, it's more work than I actually planned, but let's get into it. I've made the sleeve and the stud insert for the tube, so that all should go together rather nicely. and I can weld the sleeve in at the ends and also just split the tube a little so I can weld the sleeve along its length. The bolt is only welded at its head. It has been turned down to the same diameter as the sleeve. There's a fairly solid hunk of weld in there, but I don't think I've affected the temper of the 8.8 bolt into the bit that really counts, which is in the thread and in the shaft. The radius arms or trailing arms are, amazingly enough, Honda Civic tie rods at the back, and then at the front grafted into some 1-inch tube with rod ends front and back. The front rod ends will be drilled through the frame and fitted with crush tubes. Now, they're actually not attached to any node at all, but because their forces push along the length of this chassis rail, I don't expect there's going to be very much bending backwards and forwards, and the load is pretty well going to be along the length of the tube. Effectively, this is a Multilink strut suspension with a McPherson strut there, taking load up to the top strut, plate. But really most of the suspension loads being carried in torsion or compression by this rear control arm and this forward control arm. The reality is, of course, that everything sets everything. Both of these rods, and to some extent the radius rod, can set toe, and the majority of camber is set through the adjusters on the top of the strut tower, moving the pillow block. I did have a slight crisis of confidence that in the normal range of motion this whole assembly would bind when it was trying to move. However, looking at it and having played with it also, as the suspension goes up and down, this radius rod is going to arc, which means it'll pull the whole unit backwards and forwards. And the net result is that up and down movement will result in some toe-in of the wheel, which, although not desirable, is not a terribly bad thing. It's certainly much better than toe-out. While this is happening, the strut can move backwards and forwards and turn slightly in its pillow block, so it can take up any strange motions coming through from the radius rod. The control arms aren't set in place precisely yet. There's still some adjustment to do, particularly to make sure that the CVs and splines don't bind through the movement, through the full movement. Not that there's a lot of movement. It's 30mm in bump and 30mm in droop. Having such long sleeves on the control arms means that I've actually got quite a bit of adjustability that I can use, and thus not use up adjustability in the threads before I need to. These will just simply move out, and when I get the entire control arm to the correct length, then I can weld around there and weld up the seam, and the control arm will be exactly right. So the rear suspension is more or less in place. I still have to articulate it and see the exact length of the arms and whether I've got any binding, etc., etc. But that's for another day. We'll sign off at this point. Voila.